Today we're going to begin talking about our unit on factoring. And the thing to remember about factoring is that factoring polynomials is like the reverse process of multiplying polynomials together. And so you've seen examples in our previous videos about what it looks like to multiply monomials and polynomials together. Today we're going to be doing the reverse, and we're starting that with talking about the greatest common factor, or what we call the GCF. Now, a greatest common factor, you've heard the term before in previous grades through middle school and the upper elementary school levels, but today we're going to have a refresher course, and we're going to introduce what happens when you have variables involved. A greatest common factor is the largest factor that divides evenly into each term of an expression. And the new part for today when dealing with the variables is that when you have variables and you're looking at their exponents, you will always factor out the variables that have the smallest exponent. So that's a very important rule that we're going to have to remember for today. Let's look at example 1a and b. We're going to be looking for the GCF, and that will be all that we have to write down. So let's take a look first at the coefficients. That'll be the easiest to start off with. We are looking for the largest factor that can go into 4, 12, and 8. And the largest number that divides evenly into those three numbers is the number 4. Now, as far as their variables are concerned, we want to take the variable that they all have in common and take the smallest exponent of that. Since they all have an x, we're going to be factoring an x, and we're going to be using the smallest exponent. And the smallest exponent is this x to the first here. So we'll attach that to our 4. And 4x will be our GCF, for example, 1a. And what that means is that 4x cubed, 12x squared, and 8x are all divisible by 4x, our GCF. For example, 1b, we look at our coefficients first, and we see that we've got 15, 45, and 30. There are several numbers that can go into those three, but we are looking for the largest, and the largest number that factors into those three is the number 15. Now, all three of these terms have variables. All three of them have an a, but only two of them have a b. We see that we've got a b cubed and a b squared here, and our 30a squared is missing that b term. So as far as factoring a GCF for variables, because they all have an a, we're going to be able to take an a, but because all three of them do not have a b term, we're going to have to leave off b for our GCF. Since we did take an a, we'll have to do the smallest exponent, and the smallest exponent for my a's is this a squared. So our GCF, for example, 1b is 15a squared. That is the largest term that divides evenly into all three of my monomials in my polynomial. Let's take a look at example 2. We are still going to be looking for the GCF, but this time we're going to also be writing what's left over. So let's take a look at our coefficients here. We've got 3, 12, and 15. The largest factor for those three would be 3. Now they all have an x, so we're also going to be using x in our GCF, and the smallest x exponent is 3. So we now have our GCF, 3x to the third, and now what we want to do is draw some parentheses, because we're going to be writing what's left over inside these parentheses, and we're going to do that by dividing. So we're going to look at this first term, and we're going to divide it by 3x cubed. 3 divided by 3 would be 1, and x to the fifth divided by x to the third, when you divide common bases, you subtract their exponents. So 5 minus 3 would be 2. We've got negative 12 divided by 3, that's negative 4. And x to the fourth divided by x to the third, we subtract their exponents and get x to the first. 15 divided by 3 is 5, and x to the third divided by x to the third is just 1, and 5 times 1 is 5, so we know that we've got that one. And I can check this So this would be my answer, and if I want to check to make sure I got it right, I can distribute back, and when I multiply it back, I should be getting the same thing I started with. So let me see if I did that right. We've got 3x cubed times x squared. That would be 3x to the 5th. 3x to the 3rd times negative 4x would give me negative 12x to the 4th. Same thing with 5. That's going to give me 15x cubed, and let's check. This in red should be the same thing as what we started with, and it is. So since I got what I started with, I know that I did it correctly, and that means that this is the answer. So that's just an easy way to check ourselves here. Let's take a look at the B example. We're going to find the GCF, and then we'll write what's left over. So we've got coefficients of 6, 12, and 24. That GCF would be 6. And all three terms have m's and n's. So we'll take out an m and an n, and let's take a look at the small variables here. M's smallest exponent is m to the 1st, and n's smallest exponent is n to the 1st. So we'll have 6mn as our GCF, and now it's time to divide and write what's left over after we factor. 6 divided by 6 is 1. M cubed divided by m, we subtract those exponents, that's going to give me an m squared. N divided by n turns into 1, so I can leave that off. The next one, 12 divided by 6 will be 2. M squared divided by m is m to the 1st. N squared divided by n is also n to the 1st. My next term, negative 24 divided by 6 is negative 4. M divided by m is 1. And n cubed divided by n to the 1st is n squared. So we've got our GCF on the outside, and what we have left over after we factored on the inside of our parentheses. And we always want to double check and make sure that we can't factor anything else out, to make sure that we didn't miss a common term. So if we look inside, we don't have any common coefficient factors. They all have variables, but they don't share any variables. So we've got an m and an m, and then an n and an n, but because all three of them don't have the same, then we factored this as much as possible, and this is in the simplified form. So this whole thing right here is going to be our answer.